In this video, we are going to see how to create row vectors explicitly typing values and using other fancy operators like the colon operator, Linspace function, etc. And we are also going to see how to create column vectors and how to index into the vectors that we've just created. Let's go ahead and see how to create a row vector by explicitly typing the values. The most direct way is to put the values in square brackets separated by either spaces or commas. Here we are creating the vector 1, 2, 3, 4 by entering the values separated by a space. We could have also done that separating the values by a comma. If the values in your vector are regularly spaced, the colon operator can be used to iterate through these values. The same vector 1, 2, 3, 4 could have been created using a colon operator this way. With the colon operator, a step value can also be specified with another colon in the form start, step, and last. For example, to create a vector with all the integers from 1 to 5 in steps of 2, we can do 1, 2, and 5. What happens if adding the step value would go beyond the range specified by the last? For example, what would happen if we did 1, 2, 6? It would start with 1, add 2, go to 3, add 2, go to 5, and if it's add 2, it would go to 7, and which would exceed 6. Hence, it would stop with 5 and give us 1, 3, and 5. Matlab also has the Linspace function that creates a linearly spaced vector. Linspace x, y, n creates a vector with n values in the inclusive range from x to y. For example, Linspace 1, 5, 3 creates 3 linearly spaced values between 1 and 5, including 3. Vector variables can also be created using existing variables. For example, let's go ahead and create two variables, v1 and v2. v1 is 1 to 3, so it's giving us 1, 2, 3. v2 is the variable 1, 2, 5. So v2 is 1, 3, and 5. Let's go ahead and create a variable v from v1 and v2. Here, v would have the elements of v1 followed by the elements of v2. This is how we could concatenate two vectors in Matlab. So we've seen a few different ways to create row vectors. Let's go ahead and see how we could create a column vector. We can create a column vector by explicitly putting the values in square brackets separated by semicolons. We can also create column vectors by simply transposing a row vector. For example, we could first create a vector, a row vector, 1 to 4, and transpose it. And this would give us a column vector. So we could use all the special functions like the colon operator or the Linspace function and then transpose the vector to get a column vector. Now that we've learned how to create a vector, let's go ahead and see how we can access the elements of a vector. A particular element in a vector is accessed using the name of the vector variable and the element number in parentheses. In Matlab, the indices start at 1. For example, in the slide, we see that the fifth element of the vector is 9. Let's go ahead and create a long vector. We can access the fifth element of the vector v by giving 5 in parentheses of v. So we do see that the fifth element of the vector v is 9. A subset of a vector, which would be a vector itself, can be accessed by using an index vector which specifies the indices in the original vector that is to be referenced. For example, say we want to access the first, fifth, and the ninth elements of the vector v. We'll create an index vector 1, 3, and 5. We can access the first, third, and the fifth element directly by saying v of idx. So the first, third, and the fifth elements of the vector v are 1, 5, and 9. You can also get a subset of the vector which satisfies a condition, and this condition is called logical indexing. Let's say we want all the elements of v that are smaller than 10. We can get all the elements of v which are smaller than 10 by saying v of v less than 10. Here, we generated the index vector by the condition v less than 10, and this is called logical indexing. We will see more about logical indexing in further videos.